Welcome back to Science 10. This is the FM3 package, and this is the Recognizing Forces question sheet. And the sheet suggests you visit these two pages on the net. So we'll quickly take a look at those two pages. A lot of it we've talked about already. Then maybe we'll do a couple of these. So the meaning of force: a push or pull on an object in a certain direction resulting from the object's interaction with another object, etc. And they talk about contact forces, action at a distance forces. So contact forces we looked at: frictional forces, tension, normal, air resistance, applied force. Forces that are hard to see though: gravity. We don't see a hand pulling an object downward, but we know the gravitational force is there. Also magnets have a magnetic force. There's also an electric force. The Newton is the force is a quantity that is measured using the standard metric known as the Newton. It's abbreviated to be a big N. To say 10.0 N means 10.0 newtons of force, or if you take physics later on, Newton is the amount of force required to give a 1 kilogram mass an acceleration of 1 meters per second. And force is a vector quantity. It has a size and a direction. So for example, here we have a force pulling downwards. We can see that it has a size because of the length of the arrow and the direction of the arrow. So back in FM, I believe 1, you had a few vector diagrams that you tried. So this kind of stems off of that. Table is pushing upwards on the box. We can see that there's a force because there's an arrow, and the arrow is pointing up, so it's a certain direction. So a size and a direction. And of course, in this scenario, the book stays still, or if it was moving, but usually in cartoons you draw these lines here indicating movement. So here we have to assume it's at rest. Over here, the book was moving to the right. Up and down forces balance. We have a friction force all of a sudden interacting. So of course the box will slow down and eventually come to a stop because there is an unbalanced force. Whereas here we just had balanced forces. So the unbalanced force in this whole scenario, since the up and down force balance each other out, the unbalanced force is 5 newtons to the left. Okay? So that was the first page they wanted you to look at. The second page, types of forces. We talked about this in that help sheet there. So applied force, gravity, we talked about all of this stuff already, so there's no need to go through all of it again. Confusion with mass and weight. Mass, your mass represents all the stuff that makes you up. Okay? Whereas weight is the force at which gravity is pulling you down with. So gravity is pulling down you with a certain force, that is weight. Whereas mass is just all the stuff that makes you up. Okay? And then we have other stuff here, coefficient of sliding friction. That comes into play later on in physics, so you won't necessarily have to worry about that. Also, more detailed free body diagrams. We'll look at that with the very last sheet of the booklet, so we will be coming back to this page. Okay? So for now, if we look over here, you're to look at some scenarios here and determine which of these are present. Present or absent. Are they there or are they not there? So a block is hanging, it's at rest, it's not moving. It's hanging from a ceiling by a piece of rope. What forces are acting on it? So to give you a hint with this one, yes, definitely gravity, so you can highlight that. And you can say we can assume this is on Earth, so there is gravity. Spring, nope, and you could use it as a reason because there's no spring. Tension, yes, a rope has tension. Normal force, that's absent because, if you recall, a normal force is what happens when two surfaces are touching each other. So an upward force due to that surface. So that's definitely not there because it's hanging, it's not on the ground. Friction, absent, it's not moving, so we don't have to worry about friction. Air resistance, again, air resistance comes into play when you're moving. It's not moving, so we can say it's absent there. Okay, so that's what you have to do for each of these. Highlight each of these and write just a quick little blurb there about what you think is going on there. Okay, and so try your best with that, and then if you're having any trouble, just come to me and we'll take a look at possibly what's going on. Maybe I'll do another one with you here. So I did number 1. Maybe let's look at number 3. This tends to be a tricky scenario. A ball is shot into the air with a spring-loaded cannon. Consider the forces on the ball when it's in the air. So we don't care about how it was launched. All we see the ball is going up in an arc and then going downwards. So yeah, there's definitely gravity because we see it was moving upwards and then it's moving downwards. So yes, we assume it's on Earth, and there's gravity. Is there spring force? Nope, because I don't see a spring. Tension? Nope, because I don't see a rope. Normal? No, because it isn't on a surface. If the ball was on the ground, there'd be a normal force, but no, it's in the air. Friction? Again, it's not in contact with another surface, so no. Air resistance? Yes, because it's flying through the air, and you know that if you're running, you can feel the air on your face, or if you stick your hand out of a car window as a car is traveling, hopefully safely, you can feel that air resistance, the air hitting it. So definitely air resistance is playing a part in this scenario as well. So really, because the ball is slowing down and then speeding up, there must be an unbalanced force on this object. And of course, we have air resistance pushing up on it. When it's falling down here, it's pushing up slightly, but we have gravity pulling down to a very large extent. So that's all the forces. Those are all the forces that would be exerted on that. Air resistance and gravity. Air resistance working against it. Okay, so go ahead, try the rest of those. Highlight the ones you think apply with just a short little explanation for each. See you again.